Hey, welcome back, AP Calculus students. Today we're looking at 4.2 Implicit Differentiation Part 2. So we're asked to find the tangent and normal lines to this equation, x squared minus xy plus y squared equals 7 at the point 1 or negative 1, 2. So the first thing we need to do, right, tangent line, we got to find our derivative with respect to x of our equation. So let's go ahead and do that. So 2x minus, we have to do the product rule here, right? Because we have an x times a y. So maybe we'll write this on the side. Let me change colors so we know that we're doing our product rule. So our product rule says u dv plus v du. Our u is x, our du is 1. Our v is y, our dv is dy dx. Okay, so let's go back in here with the orange. So u dv, so x dy dx plus, and we should put a parentheses around here because we're subtracting this whole thing, v du, so y times 1 is y. And then we have the derivative of the third part is 2y dy dx equals, and then the derivative of 7 is 0. Okay, so what we want to do here is we want to solve it for y. Let's distribute this minus sign just to get it out of our way. So 2x minus x dy dx. Minus y plus 2y dy dx equals 0. We're going to move the dy dx's to one side, so we're going to add the y dy dx, and then we'll subtract the 2y dy dx. From both sides. So on the left hand side we end up with that's gross. X dy dx minus 2y, 2y dy dx. These cancel. Alright, so we're going to factor our dy dx out. And then we just got to divide by x minus 2y. Those will cancel, so this is what our derivative with respect to x looks like. To that, we just got to substitute our x's and our y's. So let's substitute our x and our y's to find the tangent slope. Our x is negative 1, so 2 times negative 1 minus 2 over negative 1 minus 2 times 2 is going to give us negative 2 minus 2 is negative 4. And then 1 minus 4 is negative 5, so that's going to be positive 4/5. So let's just do our tangent and normal line. So tangent, remember we're using point slope form, right? So we're going to do y minus 2 equals, our slope is 4/5, x plus 1. Our normal line comes from the same point, so everything else other than the slope looks the same. The slope is the opposite sign reciprocal. So there are your tangent and normal lines for this equation using implicit differentiation. Okay, so again, practicing the normal and tangent lines because they're guaranteed going to come up on your test, and I want us to be super comfortable with it. And knowing that to find the tangent, we just have to find the slope using the derivative. And then the normal line is just the same equation, except for the slope would be the opposite sign reciprocal. All right, good job. let's look at page 2. So this one is saying find the second derivative. Now the notation's weird, so d squared y over dx squared, like it's inconsistent because the squared is on the d on the top and the squared is on the x on the bottom, but just know that this means the second derivative. Another way to write it would be y double prime. Okay, so let's go ahead and do that and see why this one's a little bit complicated. So what we're going to do is we're going to do the derivative, the first derivative first, right? So we're going to say d dx, or we could say dy dx, right? Equals, and then we drop down 3 times 2 is 6x, and then subtract 1 from 3, which is 2. And then we're going to do minus 3y squared, so the derivative is going to be 6y, 6y, and then we got to make sure we do dy dx because it's not in terms of x. And then we're going to say it's equal to 0. Okay, so we're looking at this thing here. Now what we're going to do here is we're going to solve this for dy dx, just like we did in the last one. So actually I should probably just take this away because it's going to confuse us. But all right, so the derivative of y with respect to x, we're going to move our, well, it doesn't matter which way we move it, but let's move our 6y. So that's gone. And then if we want to get dy dx by itself, because we're trying to find the derivative with respect to x, then we divide by 6y, and actually the 6's cancel out. So the derivative of y with respect to x is y squared, or x squared over y. Okay, so now that we found our first derivative, whoops. So we're going to make a note of that. That's y prime. What we're going to do here is we're going to derive it again. So then we get, this is a quotient rule, right? So quotient rule, our u is x squared, du is 2x, our v is y, and then our dv is dy dx. Okay, so let's do that. So it's v du, v du minus u dv, so x squared dy dx all over v squared, which is y squared. And then the derivative of the derivative y with respect to x is going to be the second derivative for this side. Okay, so here's the problem though. Because we have this dy dx and we have this d squared y dx squared on the right side. So what we're going to do here, and it's kind of neat, we just have to substitute at this point our dy dx, which we already found here, right? Our derivative, our first derivative is x squared over y, so we can plug it back in. So we're running out of room here. Let's see if we can fit in here. So we have, let's just arrange this nicer. So we have 2xy. Then we're plugging in the x squared over y. So we have minus x. Well, x squared times another x squared is going to be x to the 4th over y. And then we have over y squared. Oh, this is turning out to be a mess. I didn't leave myself enough room here. But let's jump to another thing. So 2xy minus x to the fourth over y squared. Okay, so from here on out, it's going to be just some algebra. What we can do here is we can say that we're going to multiply by the reciprocal, right? We have this thing on top, our numerator. And we're going to multiply this by the reciprocal of y squared, so 1 over y squared. And then we're going to distribute, so we got 2xy over y squared minus x to the fourth over y cubed. And then we might as well go ahead and cancel one of the y's in top with one of them in bottom in the first term. So we have 2x divided by y, over minus x to the fourth over y cubed. And this would be our second derivative. Okay, so again, an example of where calculus can be hard because of the algebra stuff and remembering how to do what we're doing and making sure we can substitute. So the key here is that we substitute back in at the end because we already know what our dy dx looks like. We can substitute it back into our equation for the second derivative, just to simplify it, to make sure that we're just in terms of x and y and we don't have any stray dy dx's in there. Okay, and the last two are pretty easy and straightforward, but it's something that we need to keep revisiting because some of us make mistakes here still. So remember, anytime we have a radical, we can change that to a rational exponent. The top is the power, the bottom is the root. For this one, we don't have any power, right? So we're going to assume the power is 1, and then our root is the square root, so that would be the second root. So really, we're just finding the derivative with respect to x of x to the 1/2. And then now we can apply our power rule, right? So we drop down our half, and then we subtract 1 from the half, and then it's just the negative half. Keep in mind, if you do want to, well, this is good, right? But keep in mind, if you do want to convert this back to a radical, that the negative means the reciprocal of, so we have 1 over 2 still in the denominator, and then the negative exponent is going to drop our x to the 1/2 back into the denominator. And then the power is 1. We don't need to put the power 1, but our half, the 2 underneath, means that we're taking the square root. So this would be the simplified version of this. Okay, and then same thing for the second one. This time we don't have a root or a power, but we are going to just apply the power rule here. 2/3 drops down. And then when we subtract 1 from 2/3, we get negative 1/3. So this is good, right? But for those of us who want to convert it, then we'd have 2 over 3. Well, the x is now in the denominator, right? Because we have this negative. Our power is 1. We don't have to put it on there, but our root this time is 3. So this would be the simplified version of the top. Okay, so that's it. Just some practice with some of the harder implicit differentiation stuff, and just a reminder about our rational exponents and how we can use the power rule with them. Okay, good job today.